All right, today we're going to crack open a real GCSE computer science exam question. We're going to break it all down, step by step, and I'm going to show you exactly what examiners are looking for to hand out those top marks.
Okay, so here's the game plan. We'll kick things off by setting the scene. Then we'll tackle each part of this exam question, from justifying a choice all the way to calculating storage space. And we'll wrap it all up by pulling out the key techniques you can use on pretty much any question.
Okay, first things first, we've got to understand the context. Any great exam answer really starts with getting your head around the scenario. In this case, it's all about a musician who's in need of a new storage drive. So this is the exact wording from the paper. And this isn't just some random setup, It's specifically designed to see if you can apply what you know technically to a practical, real-world problem. That's a huge skill they're looking for.
Now for the first part of the question. This is a classic justification task, and at 4 marks, it's a pretty big deal, so we've got to make sure we know how to absolutely nail it.
Right, listen up, because the most important word here is justify. You don't get marks for just picking one. Nope, you have to make a choice, magnetic or solid state, and then build a really logical, solid case for why you chose it.
So before we even peek at the model answer, let's just think this through ourselves. A magnetic HDD, yeah, it's cheaper, but it's also slower, and with all those moving parts, it's not as tough. On the other hand, you've got a solid-state drive. Way faster, way more durable, and smaller, but it's going to hit your wallet a bit harder. Weighing these pros and cons, that's the secret sauce for a great justification.
And boom, here it is, the perfect answer, pulled right from the official mark scheme. Look at how it hits 3 totally separate points, and they're all tied back to our musician. It's durable, it's got fast access speed, and, I love this detail, it's quieter. I mean, how perfect is that for someone recording music? All right, next up is a quick one. This is a super straightforward 1-mark question. They're just checking to see if you know the different types of storage out there.
So we've already talked about magnetic and solid-state drives. The examiner just wants to know if you can name that third major category of storage. Got it?
And the answer they're looking for is optical. We're talking about things like CDs and DVDs, the stuff that uses a laser to read and write data. Simple as that, and that's 1 easy mark in the bag.
Okay, moving on, we've got a multiple-choice question. This one is all about testing your knowledge of storage units, and more importantly, if you can accurately compare their sizes. So, here are our options. Now, you can't just guess here. The only way to solve this is to get them all into the same unit so we can compare them apples to apples. Let's go with megabytes. That seems like a good middle ground.
Okay, let's start with the big guys. Remember, a terabyte is 1,000 gigabytes, and a gigabyte is 1,000 megabytes. So that 0.0021 terabytes is the exact same as 2.1 gigabytes, which works out to a massive 2,100 megabytes.
All right, now for the kilobytes. Since there are 1,000 kilobytes in a megabyte, right, we just take that 200,000 divided by 1,000, and that gives us a nice, clean 200 megabytes.
All right, time for the final showdown. Let's line them all up now that they're speaking the same language. We've got 2,100 megabytes, 300 megabytes, and 200 megabytes. It's so obvious now, right? 200,000 kilobytes is the smallest value. That's our winner.
On to the next part, a 2-mark calculation. And here's a massive tip for any math question in an exam. Always show you're working. Seriously. That way, even if you mess up the final number, you can still grab some of those precious marks.
So the task is pretty straightforward. Figure out the total space needed for 1,000 recordings that are 3 megabytes each. But, and this is the crucial part, the final answer has to be in gigabytes. So let's look at how you get the marks. You get 1 mark for doing the first step, multiplying the number of files by the size of each one to get 3,000 megabytes. Easy enough. You get the second mark for correctly converting that to gigabytes by dividing by 1,000. And there we have it, our final answer, 3 gigabytes. See? Showing both the multiplication and the conversion is how you make sure you walk away with both of those marks. Don't leave points on the table. So let's zoom out for a second. What have we actually learned from digging into this one question? Because it's about way more than just storage. It's really about exam technique. Honestly, you should think of these as your golden rules for the exam. If the question says justify, you have to give your reasons. If you're comparing values, get them in the same unit. For any calculation, show every single step. And always, always read the command words carefully. They are literally your instructions for how to get the marks. So that was our breakdown of just one single question.
But the real takeaway is this: where else can you apply these strategies? Mastering justification, conversion, and calculation isn't just about this question. It's your key to unlocking top marks across the entire exam paper.